K8BYP in the Radio Shack, still dinking around with the TR3, despite all the work I've done to this rig over 6 years, literally. Of course, not steady work, but spanning 6 years. I have never done a complete, full test of the transmitter output as far as percent modulation and clipping and distortion and such. I've been fighting complaints of extreme distortion on sideband, but apparently not on AM, which suggested bounce modulator problems, and the bounce modulator was not good. But see, there can't really be any problems in the sideband modulation system because I've just about replaced all of it. The only thing left is V15, a tube amplifier. I'm not going to replace that with a solid state unit which has more distortion. Tubes are much cleaner. So with the new bounce modulator tuned literally to millivolts, it ought to be working. So I got on the Dahlonega, Georgia Web SDR last night on 7295 on 40 meters. And I talked to it and listened back on the cell phone, and I heard a lot of distortion when the mic gain was turned up to, that's transmitter gain, to a little bit past that setting. Turned up to 11 o'clock, bad distortion. That corresponds with where I was setting it in AM, and setting that high started bringing significant peaks in the plate current, and that guarantees that it's making more output power. But the question is it too much? Is it incorrect? Is it clipping? And the more important question is, at lower or proper modulation levels, are the modulation peaks corresponding with the peak CW output, which means full power from that transmitter? At lower modulation levels that did not produce distortion, that also corresponded with the plate meter basically not doing anything. It pretty much read idle and an occasional peak. Well, voice is a problem because voice is very peaky. On letters like P, there's a very high modulation peak. An average figure for modulation is about 20% duty cycle. So for 100 watts CW, we might expect on sideband for a meter to read 20 watts. And this is why we go to speech compression, to get rid of the peaks and bring the average modulation level up, so the transmitter in sideband is making more power, producing more power, and it works. But this radio doesn't have that. So how to verify that with a lower mic gain setting, which results in a clean signal, which is required. We're not permitted to have trashy signals on the air. Is the PA stage producing full power, about 170 on voice peaks, the same as 170 on CW, average of the carrier envelope, which is perfectly clean at 170 watts. I checked it at 7 megahertz with a scope. Nice sine wave. But is the fact that with lower modulation drive, that the plate meter's not reading much of a peak, does that or does that not indicate a problem in the final amplifier? That's kind of a sticky thing to test because a peak reading watt meter can't show clipping. It takes an oscilloscope or a station monitor to show clipping. There are a couple of parameters of modulation besides frequency width and information rate and all that jazz. But in practical radio, there's percent modulation, which might be kind of sort of called modulation depth, I think. And also whether it's excess and clipping. Those are the two biggies. So, how to test that? Well, we don't do this on the air. We do it with a dummy load. And I torched a 250 watt dummy load in that enclosure. That heat sink for the stepper motor driver is probably not big enough for this transmitter. So I replaced that with a 75 ohm load, and it's setting in a pan with some shallow water in it, where the water covers much of the heatsink fins. So that'll take some of the heat away. The PL259 is an input from the TR3 transmitter output. The BNC is a takeoff, I think it's 6 milliwatts over two channel scope. Channel 1 here is from the dummy load, the transmit signal from the PA. Channel 2 is the microphone input signal, taking the transmitter as a black box, as a whole. And what this shows is that when the transmitter gain is increased much past 9 o'clock, which is here, that's looking head on. When it's increased to about here, and I drive the mic, maybe get a little too close or speak too loudly, the peaks start to flat top. Here is bad flat topping. And here, the entire envelope is flat topped. And this is where I was running it at, so that correlates precisely with complaints up here of we can't even understand what you're saying, because everything was clipped because I was overdriving mic input. The problem with this microphone is this is a 1970s microphone, I believe, used with a transmitter that was supposed to have a crystal microphone. And this dynamic mic will have much more output than the old crystal mics. And it's a bit more difficult, or very difficult, to find crystal elements these days to replace the old ones with that work. So dynamic mics are essentially it. The dynamic mic is basically a speaker backwards, and they can generate a couple volts peak to peak. So here are the waveforms on the scope. The lower one, you can see, is picking up my voice speaking from way back, from almost a foot away. But as I get up to it, you'll see the modulation from the microphone, the audio signal, which is, it's going about 3 divisions at 200 millivolts, about 600 millivolts peak to peak. And that modulation signal can be reckoned as 2 different peak-to-peak levels. The absolute max peak-to-peak, which is where we're required to reckon transmit power by FCC, and then the peak-to-peak amplitude of the average of the signal. And I know I'm confusing terms here, but that's how it is. There'll be the spikes. You can see spike, 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 great big transients at 600 millivolts, and then the lower level sine or voice waves down in there about 1 division. And that illustrates the huge difference between the peak and the average, so to speak, of a audio voice envelope. But up above, when I key the transmitter, we can see that there is bigly clipping. Hello, 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 hello. See the flat topping? The very tall envelopes are flat on top and bottom. That's called flat topping. If I reduce my voice a bit, then that goes away. And when I turn the mic gain, the transmit gain, up to 12 o'clock, we get this awful looking disaster of literally square. The peaks are squared off. It's clipping so badly. And I did verify by looking at the full power output CW carrier envelope on the scope and seeing how many divisions that was on the scope screen, on the scope display, and then moving to a voice emission and seeing that the peaks in the voice went to the same level. So that guarantees full voice PEP output. So that indicates that this transmitter is working correctly with regard to that. That isn't, maybe not a percent modulation test. There are ways to do that. But all these things fit together to show that when properly operating, that plate meter isn't going to show much of a peak. It would occasionally peak up maybe to 0.15, but that's a slow meter. It's not intended to be a modulation indicator. The S meter kind of sort of does that. And that is kind of sort of going up to S9. And if I recall correctly, I either read in the manual or heard that the max deviation on the S meter ought to be about S9. That kind of seems to be what it is here. So as you can see, there's too much idle bias. Because, way too much. The idle, plate current idle should be 100 mils. There. Maybe just a shade more. Yeah, that's reading from 0 to 0.1. S meter reading of 0.4, or of 3 minor divisions. But that gives peaks of about S9. So the thing to watch for is basically modulation excursions that go to about midpoint on the S meter. And yes, this rig is designed so the S meter indicates receiver signal strength, and also in transmit, it becomes a modulation indicator, because the S meter is hung between the plates of the receive IF and the bounce modulator amp. So right about there is probably about maximum modulation. And this has proven that just because I turned the mic gain down to get rid of distortion doesn't mean the transmitter is being underdriven. It is being driven correctly. And short of a modulation quality, and I don't have a modulation quality meter. Most of us can't afford that kind of toy. And I don't have a spectrum analysis output, but the assumption is with the PA stage being correctly biased, making good power, clean signal, it's highly unlikely that anything strange is going to show up on a spectrum analysis. And having all that information, I'm not real excited about taking a 170 watt transmitter into that spectrum analyzer, which is mega bucks. That's a 2.4 gigahertz analog spectrum analyzer, Tektronix. I'm not the least bit interested in a mistake that destroys that spectrum analyzer, because that unit sitting there, and I've completely restored it, was $50,000 in the late 1980s. I ain't going there. It ain't that important. Want a rough indication of harmonics? Well, use another receiver. Couple in some signal to another receiver of maybe S9, then change your other receiver to the harmonic frequency and see if you can hear anything. It's extremely crude, but it works. So I tested this transmitter last night with N4RXV down in Georgia, and he said that he heard me testing to the SDR, and he said yes, he could hear when it went into distortion. So he generally verified the results I was seeing. And ultimately, that's what we're doing. We're using these transmitters to talk to someone out at a distance, and if what they hear is distortion, then that's not acceptable. So at this point, this transmitter is essentially perfect. I had to disable the RIT. It was just driving people crazy on sideband, because the transmit and receive frequencies weren't aligned exactly. In CW and AM, in AM it doesn't matter. Transmitter can be off a couple hundred cycles and not be a crisis. And in CW, the very goal is to have them off frequency to effectively create the side tone. Generally maybe 300 to 1,000 cycles. But in sideband, especially with these new solid-state radios, this transmitter being off frequency a little bit apparently made some serious problems. So I just got to go in and find some place to put a switch and there's no place on the front panel to do it, and I'm not drilling holes in that front panel for any price. But have to use the old CB radio operator's trick to put the toggle switch under the front of the radio, where the switch is used to flip the carrier oscillator over to transmit on the higher channels illegally. That's how they did it. I'll have to put a RIT off-on switch under the chassis because the sideband push-pull is dedicated to changing the sidebands, and the rotation is RIT. And I don't think they make a pot that's combination push-pull and turn to off. So there it is, after literally 6 years of work, off and on, with probably literally a year of testing, literally. Tremendous amounts of testing. It appears that this radio is finished. It works beautifully. And it gets just fantastic reports on the air. So there it is. It works. KBYP did it.